Okay, so I want to talk about a little bit about VR. Virtual reality is defined as getting a user inside a 3D computer generated environment. So basically, what that means is just grabbing the user and immersing in a world that it can be created through a computer's software such as 3D Max, Maya, 4D Cinema. Basically, it's trying to get a user immersed into a 3D computer generated environment that it can be created by different type of softwares that we know. And actually, virtual reality has been trying to be possible from a long time ago. Actually, one of the first virtual reality head-mounted displays, or they call it with this acronym HMND, MD. It was called the Sword of Damocles, which is basically a huge, monstrous apparatus that it was like hooked up to the ceiling. It was too big to move, and they kind of just overpose these 3D environments in an empty room. And whenever your head moved, you could see actually, like you can actually see this 3D kind of like a very polygon type of objects through a different perspective. So humans have been trying to create this virtual reality from a time ago, from long time ago, and I think in science fiction it came over one of the books that it really details about a world uh, based on virtual reality is Ready Player One, which is funny that they made the movie not long time ago. Um, After that, I think actually one before that one, it was called the Sensorama, which is basically a 4D cinema experience. It was like back in the 1960s. So it was they put this guy in front of a TV screen, in front of a screen. They play some type of video, and they put some smells that will correspond to the images inside the video, and they also have some movements and voice. So it's all about trying to immerse the different senses in order to make believe the persons that are inside this world. Right now, because technology has advanced, and I think it's more because of the smartphones that we have like these little inside our pockets that we start developing. We were able to develop a virtual reality headset. The first iteration of headsets actually they were the HTC Vive, the Oculus Rift, right? They were one of the beginnings. We needed to hook up to a very powerful high-end computer PC, and then they had this at least the HTC Vive, sorry, started with some sensors that you had to put like in a diagonal perspective inside your room, and they can detect the headset and the controllers. And the Oculus Rift started with two sensors, but without any controllers. That's why in the beginning, I was like, no, you know what? HTC is gonna get the higher end, or we talk about the virtual reality headsets. But then they came up with these really nice controllers, and they also had their own sensors, which they're just like a table in you can put it on top of your desktop. And I think there is when Oculus started taking the edge on the dispute of head-mounted displays for virtual reality. Then a whole bunch of mix came out, some created by HP, some created HP, LG, that they call it mixed reality for Windows. Also, we have something we call mixed reality, which basically they overpose these 3D elements inside the real world, which uh, led on to create augmented reality, which is the one that we use in our phones most likely, and headsets like the HoloLens and also the Magic Leap are starting to come up. They have this mini computer that you attach to your belt, and they start mapping the room, right? They map the room, and then they understand like where are the walls, where are different surfaces that they can actually put on 3D elements. and they respect that they get anchored to this point. So whenever you can see them like behind them, you can see them around them. So it gives you a sensation that these 3D elements live in the in your reality that they were calling it augmented reality. Later on, they started iterating into more into different tiers of headsets. The HTC Vive came out with the HTC Vive Pro, and they started to create in a tetherless versions, which I think the HTC is still very big, and that's when Oculus started creating the Oculus Go, which you didn't need a computer to have it connected to the head-mounted display, but it was still a little bit. It just needed a little controller to position itself, and sometimes you can get lost tracking of it, and create that motion sickness that a lot of people are afraid to whenever they try these virtual reality headsets. And they came out now. I think the latest versions are the Oculus Quest that they came up with. Oculus Quest 1. It sold really, really fast. I think the pandemic has to do a lot to do with it. And then they came up with the Oculus Quest 2, which also sold out, and that's why they're creating a third iteration. Now, this new Oculus, they have also accelerometers. They use the controller to also help position themselves, and they have, if I'm not mistaken, around 4 cameras. Now, these 4 cameras map your entire room, and then you can create an area where you're going to be playing. And it's funny because these new Oculus now they can really understand. Now they can really understand where they are at, and well, most likely there's tons of content that's from social media in VR. There's video games in VR, and they're also starting to create different applications that will help not only capacitation, like if you want to train a new employee, but also how to use a new machine. It also has been used in, for example, medical experiments when but I think this one was, I'm sorry, I think it was the Mayo Clip, but I think it's a really fun fact that you should know if you're into virtual reality and augmented reality. There was an operation when the doctor he was operating a patient, and he needed assistance from another doctor who was on the other side of the planet. So what they did is like hook up some sensors so the doctor could see what the doctor was operating, and also it was like and through the HoloLens, the doctor could see literally the doctor right next to him, like telling him what to do next. So it's this type of technology have incredible applications. Now, uh, now that probably you guys are tired of seeing just the logo, we're gonna start talking about real-time engines. Have you guys heard about it?
A little bit.
Okay. So there are different type of real-time engines, and the one that we have right here is Unity. Another one that you can find is kind of like the competition. It's Unreal. Now these real-time engines, they're called like that because whenever the user puts it inputs any type of signal, there's an immediate reaction of the application, right? Such as video games. But it also can be used in a lot of different applications: architecture, automotive and transportation, film and television, broadcast and live events, training and simulation, more uses. They're also being used to train machine learning through different video games, right? I think there's a game called StarCraft that it was used to train one of the artificial intelligence, to learn how to play, and it started beating like the top players of the world, which are all South Korean. I don't know why, but they're really good. Um, okay, now Unity, it's basically used to build 2D and 3D apps, of course, virtual reality applications. What it does, it's I think the main difference between these two is that you can do more out of the box from Unreal. Unreal is quite powerful, as you can see. The graphics that you can create with Unreal are great, uh, but I think there's a little bit more of a curve of learning, and I I think if you are a professional, you're already like have a lot of years into the industry, this is a great tool. If you are starting to learn, if you start like thinking about either making VR experiences or video games, or literally just dipping your feet a little bit inside the real-time engines, Unity is perfect. It's easier to learn. It has a better community. It has, I say better because it's bigger. So whatever problem you have, they probably have it as well, and somebody already created a post about it, and somebody solved it, right? So that's why it's kind of like better when you're starting to learn about real-time engines, because there's so many options that you can take in order to learn or in order to solve any of the problems that you might get in advance. Now, if you are new, you're probably gonna want to uh, download the VR, the Unity. Unity, if you go to individual, there's a personal free version. There's also one for Unreal. Actually, if you guys see in Discord, there's a Unity text channel right here. Uh, Let me. So I think you guys can see it. I'm gonna grab a link. I'm gonna share with you in that text channel a link for a document, the one that is above the Unity, the intro Unity VR. This one that says Unity text channel. Now on that link, you will find the link for this to get to download the Unity free and free personal version. And also it's going to declare point and point what we're going to be learning in this workshop. So first you download it, it will tell you to give you access to your computer, to basically you pass all the routine of downloading a normal application, and whenever you're done, you will open Unity Hub and it will look something like this. Now here you have all your projects. You can add the projects that you can download or find on the web, or you can create your new one. Here you can have the Unity Learn, which comes with a lot of projects, tutorials. Some of them are VR. Some of them are for beginners in case you wanted to learn how to start working with C#. Now this is an important part. Unity's base language is C#. So whenever you're starting to code anything, it's going to be in that language. A previous version, an old version, actually, you could code with C# and also JavaScript, but they just threw out it. It wasn't working with their architecture anymore, so they decided to just leave C#, which is kind of like the core version of Unity. Now, there are different installs that you can get. If you go to installs, add, and it will give you different official releases. The one that says LTS, LTS stands for long-term support. So that means that Unity is going to be working on it and it's going to keep supporting it even if they release new versions. So whenever you download a version, make sure that it's an LTS. The other ones, for example, 2021.1.4, maybe a little bit buggy or maybe still in a beta version. So it's always safe to go with an LTS version. Now, let's say we want to create a new project. So whenever you create new, I'll give you these different templates of projects that you can create. From AR, you can create even a VR, but we're gonna use 3D right now. It's basically the same. We have 2D, which is basically it's more entailed for 2D 2D video games or 2D apps, high definition render pipeline, which basically focus into have a very high in textures and PBR, which is physical based render, which are pretty nice. It makes look everything great, but we're gonna use 3D for this workshop. I have already a workshop there, so I don't want to mess this up. And universal render pipeline, which is basically 3D on steroids, but not as good as high definition render pipeline. So once you hit create, it will take a while. It will copy the template library. It will start rendering. So far, guys, do you have any questions about it? If you do, please feel free to type in the text channel, or just to shout out inside the voice channel here. No, we're good? Wow. Okay, guys. Do any of you guys own a headset, an actual VR headset?
Yes, we have the Quest 2.
You guys have
Yes.
Quest 2. How do you find it so far? Do you guys like it?
Yeah, it's good. It's a lot of fun. Takes a little while to get used to the motion, but yeah.
Yeah, it can be also heavy on the eyes.
Yeah, I wear glasses, so it's a little difficult sometimes.
Yeah. Okay. Well, now you open Unity, you will find that you have different windows. The one in the middle is called your scene. Basically, here you will find everything that you have imported into your scene. Right now, it starts with nothing and with a default skybox. This is a directional light, and this is a camera. The camera is how the game will be perceiving. Another window that you will have right next to the scene is the game. This is kind of like the perspective that you have from the camera that you have on your scene, right? So if you move the camera, although you wouldn't notice, like it will change right here. You will notice because there's nothing in our scene, which leads us to our hierarchy. Here in our hierarchy, you can find in text and in our game objects everything that we have in our scene, our main camera and our directional light. Everything that is inside in our scene is a game object. Okay, even if it's a camera, it's a directional light, it's a cube, if it is a player, everything is a game object. That's kind of like the root of everything. All the game objects have different properties. If you go to your inspector, which is this one that you see to your right, you will see the different properties that game object has. For example, it has the one that comes with every game object, even the empty ones, is the transform, which is basically the position, the rotation, and the scale of your game object inside your 3D environment. Now here, these are vector 3. Sorry, this is a vector with 3 axes. So you have X, Y, and Z, and you can see it represented in these little arrows. The blue one is Z, the red one is X, and the green one is Y. Now, in order to move your object, you can either use these arrows to move your camera, for example, or your light, or you can move it from your inspector right here. If you change the values on Y, you can see the directional light is moving, your values on X, etc. You'll find the same with the camera. And for the camera, it has an extra property, actually two, which is the camera property, which comes with different type of elements. Now you can see the field of view of the camera. You can open or you can close it like in a real camera. You see the projection, orthographic. It will create this kind of like square type of projection or perspective. Cooling mask, basically we're telling it to see everything. You can tell it to ignore certain type of things by using the cooling mask, which is based on the layers. Here we will find the different type of layers that we have on our scene. We can add a different layer, and for example, we can let something a little bit more advanced, but we can tell like, oh, this layer will never touch this layer, even if they are on the same physical space inside our scene. If the layers don't touch, if you tell the layers don't touch each other, then it will be like if they were not in the same position, though. Of course, in a real world, that wouldn't happen because two objects cannot occupy the same space, right? And these things have to do a lot of physics because it's based on a physics engine. Now that we're going through that, I think probably is a good place to start you guys showing the project settings and the preference of your Unity editor. Now, if you go to project settings, you will get a window that looks just like this. Here we have a lot of different things. We have your audio, you have the preference from the settings from the editor itself, some external tools that you can attach, graphics, your input manager, your package manager, which basically will let you import packages from the Unity store, or even packages that you have purchased, and packages that they are for free and you will need them in order to create the different type of projects. In this case, we're gonna download some packages to start using our Oculus. Now, this is the one that I want to show you guys. This is the Physic project setting, and for example, you can add you can start messing around with the gravity. Now, right now it has, you know, our gravity is 9.8. And then basically you can start adding into that input, or adding into that input, or even making our gravity a little bit less. All right. So you can start messing around with the physics of your editor right here. Threshold simulation. This is the layer collision matrix. This is the one that I was telling you about. For example, if I don't want the water to touch for example, the the default layer and the water layer, they won't touch. So whatever I put in the default layer, it will never touch the water layer. We're gonna come back to this whenever we start adding more stuff into our scene. It will make more sense, but it's good that you guys know where is the project settings and what can you do with it. You have your player settings. We're gonna come back to this one. You can set the quality if we want the quality of our project to be in ultra, to be very high, medium. It depends on what you're building and what your basically the scope of your project. Services will help you whenever you have your own game and you want to add ads, or you can use the analytics. You can just collaborate, which is basically a version control. It will let you have like different version of the projects in different machines, and then basically merge those branches whenever you have multiple people collaborating. You have the tags and layers, which is basically here you can start adding new layers. You don't have to like only use the default, the transparent, the ones that we showed you guys like right here. You can add even more and create your own layers and tell them not to touch each other or to have different functions. And the tags will help us to identify certain game objects inside our scene. For example, the main camera, it will always have the tag of main cameras. That's how the game detects like, oh, this is the game camera. Whenever I go to my game mode, I know that I have to find that game camera and start using it. So that's tags and layer. We have Text Mesh Pro, which will let us use a mesh to create text, to create literally text. So you can, if you want to add something for the player to read inside your game, you're gonna use it. Timeline, we're gonna see a little bit about it. Version control, like we're gonna use different version controls, and the one that we need to learn today is the XR plugin management. This XR plugin management will help us to download the software development kit from Oculus that would let our Oculus Quest connect to our Unity editor. But we're gonna go back to that project setting. Right now we're gonna go back to hierarchy, and also I want to teach you guys how to move inside the scene. So if you go to your scene and you select, for example, the camera, and you press F, F means focus, so that means that I will focus into this game object. It's better that whenever you're using Unity to use your mouse, so you can use your scroll wheel to zoom in and zoom out into your game object inside your scene. If I press my scroll wheel to have that third button, it will come out with a little hand, and then you can pan around the scene. And also if you press Alt and the left click, that means that I can start rotating around my game object. That's how I start like moving around this scene, and it will help me to find stuff, or whenever I'm constructing a level, it will help me to move around. You can also find it right here. You have the hand tool, you can rotate, which also you can use the shortcut with this E. With E you can rotate the camera. You can also have scale tool, which is you can also access to R, and basically you can make our objects larger, but the camera won't work. And rec tool, rotate, and scale tool. So basically are those three just in one. And for example, let's create this 3D object. Let's create a cube in the middle of our scene.
Thank you.
I just right click inside of the hierarchy. I went to 3D object, and then I just press cube, right? It creates this game object called cube, which contains these different properties. We have the cube mesh filter and the cube mesh render, and a cube and a box collider. So what it does, this mesh filter, it's grab this mesh that it can be created in any 3D modeling software, and we can even change it. Like by default, Unity gives us the cube, the capsule, the cylinder, the plane. If I grab it a sphere, then the mesh filter will literally just grab it, put it here, and the mesh render will render whatever the mesh filter had. Now the mesh render, you can tell it will give you different properties. In this case, it will tell you the material that it's using. It will tell you if you want to cast light on it, if it will cast shadow, and if you're using probe to reflect any type of lights. Whenever you're making this scene and you have different elements, you can actually tell the light to reflect in the probe, and that probably will reflect into other objects. So that will create that effect like real light, because light bounces into different elements. And sometimes, for example, I don't know if you guys have worked in green screens, but sometimes the light bounce on the green screen into the person that is in front of it, and they have to clean that light up, because if not, like for example, it start like erasing parts of that person. So basically, this is the Unity trying to replicate that lighting physics, right? We have we see this a little bit. We have the box collider, which I'm gonna make the size a little bit right. Is this green right here? Basically, that will help us to detect any type of collisions. So whenever I throw my object and it hits a wall, then if it doesn't have a box collider, it's just going to go right through it. But if it has a box collider, then it will say like, oh, I have like boundaries. So it will just smash against a wall and then drop down. You can actually, if you go right click in hierarchy and then create an empty object, inside this empty object, and I say like sphere, I can change the name of my game object, which comes with the very basic property, which is transform. And then I add a mesh filter and a mesh render. And then from a mesh filter, I grab the sphere. By the way, if I click here, Like right now, I'm seeing the cube, right? If I click here and then I press F, it will tell me like, oh, this is your sphere, it's just inside your square. So if you guys thinking like why it doesn't look pink, is because it doesn't have a material. Whenever it shows you pink, is because the material or the shade that you're trying to apply to this object can be found. So if I go right here to materials, to element, and I click it, I can just grab the default one, which is the white one, and like you can see now it receives light, and you can see even shadows. This is our directional light. If we have a directional light in our scene, basically we just need to rotate it. As you can see, it will basically change the entire light of your scene and also in your objects. You can have different lights in your scenes in order to create really cool environments. Now what it happened right now, it's because I changed the perspective from 3D to 2D. So in 2D just moved between two axes, X and Y, and when I take off the 2D, then it let me go also in the Z axis, right? Those are the three different axes that will live in our 3D spaces. We also live in a 3D space. We also move in X, Y, and Z. Although we are always moving in the 4 axis, right? Which is time. That's something that's good to know, right? Very nerd joke. So let's add a plane. Let's create a 3D object, have a plane, and with this we'll have a ground, right? Now, even though they have colliders, we can put it like this, but the colliders won't take an effect unless you add a rigid body to each one of those elements. And even if you add it in scene mode, you can put it stuff like this. But if you go to plate mode and you add the rigid body, like things, because they cannot exist in the same space, will try to like move, and that's why sometimes have like this box where these errors. Whenever something like just jumps out of nowhere, is because maybe you have a box collider on top of another box collider. It was creating just a physics error. Now, move our camera so we can have both of our objects. And let's move these two so they can be on the main camera. If we change to game, we can see them. Okay, let's go back to scene, maybe a little bit closer. That's cool. And then we make these two up. Cool. Now, if I go to my sphere, let's add a sphere collider. There are different types of colliders. Like you can see, we have box collider, we have box collider 2D, which is basically square, capsule collider 2D, a circle collider, we have edge collider, mesh collider. Mesh collider basically will grab whatever mesh you grab and create a collider out of it. Although colliders are very processive, kind of heavy, so the less polygons your collider have, the better. That's always a rule. That's why even you have like very complex shapes, we use just a bunch of box colliders into it, just so we don't take a lot of processing power out of the application. So we're gonna use a sphere collider, and then we're gonna add a rigid body. Now the rigid body is when physics comes in, right? We can give it a different type of mass. We can try to use gravity. Use the drag, the angular drag. The drag basically is the friction, the kind of the resistance of an object created whenever it moves between a different surface. And also we have the collision detection. It can be discrete, continuous dynamic, continuous speculative. Like for example, if you have an object that like a bullet that it moves like in a really fast speed and it has to detect whenever it hits another opponent, you want to use a continuous dynamic. If it is something that like a bookcase that maybe falls at a certain time, you can have this grid. It doesn't matter, right? It's not something very specific, very hard to catch. Now, if we go right now to play mode, this one doesn't have a rigid body. Remember the square. We go play. See how our ball, our sphere actually falls and collides with the plane. It's because it has a rigid body. So now we start respecting a little bit of there's some physics applied to it, while the cube doesn't. Now, one thing, whenever you're in play mode, you can also change the position of everything. You can change some values, but whenever you go out of the play mode, those values will reset to the previous values. So whatever change you make in game mode, usually we make them just to check some errors or to try if it works better with those values. But then we have to remember those values, because when we get out of the play mode, then we know we're gonna lose all that data. So by default, the editor won't show you guys if it's in play mode, like mine. Whenever I go to a play mode, it changes everything into this blue color, this blue tint. So in order to do that, you go to edit, preference, I believe, and journal, what is this, colors, and then play mode tint. And here it is where I change it to blue. Usually it's like normal, but I change it to blue just so I remind me, like, oh, I'm in play mode. Whatever I do right now is not going to be saved. It's a good thing that you guys know that. And it's a pack, something that you guys should do just for good practice. Now, now we talk about the hierarchy, the scene, the game mode, the inspector, the properties. Let's go to our projects and console. Projects, here we have the assets, we have the scenes. Here is the scene. This is our sample scene. This is the one that we're working on right now. This is basically this one right here, and we don't have anything else, right? This is all the assets that we have inside our project. We're gonna start adding them here by dragging them from your desktop if we want an image, or if we want a 3D 3D model that we just created in Maya or Blender. We just drag them and we drop it here, or we import them directly into Unity. Or if you want an image to use as a user interface, as a UI, like the menu of a game, you just drop all your elements right here into your assets folder. Now, that's the project assets. The console, basically, here will tell you like some errors that is happening in your code. So whenever something is not working, whenever you go to play mode, it will tell you right here like, oh, there's a problem with this. That's why maybe it's not working. And we even told you the line of the code, so that's pretty handy. So that the project, the assets, and the console. So let's work with something a little bit more fun. Now, there are 3D objects. We have effects, we have lights, we have audio. We can even insert some video players. UI, this is basically whatever we see in top of our games, like the menus or everything that we can overpost in front of our actual project. And we can also add different type of cameras. So let's add an effect. One that probably a lot of people know is the particle system. Here, this particle system, as you can see, it creates this game object, and in our inspector, we can see that it comes up with this property, the particle system property, and it's grabbing this material, which is the default particle system. Now, particle system can be a little bit heavy on processing power, so be careful with it. Use it wisely. We have this playback speed, this playback time, and the particles that they burst every certain amount of time, the speed range, and everything else. So we have duration. which is basically how much it will duration our particle system. If we don't put it in looping, it will just last that amount of time, right? But because it's looping, it will keep going and going and going and going and going. Now let's create this kind of like a magical trail effect that we can put into a game object, right? So let's just start messing with the properties. We have the duration, we have looking pre-warm. It's basically so it don't start from 0 like this. It will start like already in the middle of the animation, on the middle of the particle animation. We have the start delay. Basically, it will wait a few seconds before the animation starts. The start lifetime is the lifetime of each one of the particles. If we take this down, then all the particles start dying a little bit sooner. We have the start speed, so basically the speed of each one of these particles. Now it's going faster. The 3D start size, the rotation, the start rotation, if you want to rotate it, although this doesn't matter because it's basically a sphere, so you won't notice. You can tell by the tile that it's surrounding the sphere that it's rotating, but you know, it won't really change. The start color, if you want to change the color of your particle, you can change it right here. And gravity modifier, this one is pretty good. Actually, we'll add some gravity to each one of the particles. So as you can tell, now they get expelled by this amount of speed, which we can change right here. And then as it goes affected by the gravity, and that's why I create this nice little curve to each one of the particles. Now we have the simulation speed, the delta time, which is basically the time that we're living in. Plane away, the meter velocity, and the max particles, which will I'll show you guys in a little bit like how it can work. Now you have one that's really nice is the simulation space. Right now, and this is kind of like something that you guys need to learn from now. Right now, the particles live in the local position of my game object. So whenever I move this game object, it doesn't affect the trajectory of the particles because they travel with it. It's like if they were living inside the space of this game object, right? So whenever I move it, they move with it. So if I change this simulation space from local to world, now if I move my game object, the particles actually keep their trajectory, so they're not moving with this game object anymore. They're moving in the world space of this environment, not in the local space of this game object. And now you have emission. Emission, you can have it rate by time. Okay, I need to increase the lifetime of this. So by time is basically the amount of rate you will have per second. If I turn to 0, then it won't show any. Now, if I change the rate over distance, let's say 35, whenever I move my game object, it's going to move these particles 35 at a time, right? And it also can create this maximum of particles, which is 1000, which is right here, my max particle. So if I reach 1000, you won't see particles being created anymore. You can solve that by chasing this value, let's say 3000. Now you can play a little bit more with your particles. Now all these particles have a shape. If I move this horizontally and vertically change a little bit because it's the size is in the shape of a cone. So if I want to create a more trail effect, if I change it to the side of the model of a sphere, it will react differently. So let's say radius, let's give a radius. Now let's give a 0.5 radius. Zero thickness. Okay, they still have a little bit of a. I want to look to it look to more like a line. So if I take the gravity modifier, now let's say 0, and the star speed, say 0.1. Start giving me a little bit of a line. Still, I think it's a little bit too big. So I'm gonna change the star size. It's getting there. It's getting there. So now I change my sphere. Let's change a little bit. We have velocity over lifetime, which will change the velocity depending on the amount of lifetime of each particle. But let's change something fun like sorry guys. Color over lifetime. So whenever I choose color of lifetime and I grab this gradient, I can choose the start and the end of the color of the particles, and I can add any other color in between. So let's say we start with this. This is our color, and this is the alpha of the color. So basically the transparency. So let's say it's going to start with this blue, but then as it goes dying, it will just turn transparent. Oh, sorry guys. I need to change the start color right here too. So now as they go dying, they go a little bit transparent. Let's change this 0.01. I just changed the radius of the circle, so now it has this more of a line effect, right? So let's start speed. Just gonna give the lifetime a little bit smaller. Okay. And now we have that. We also gonna change the size over lifetime. You can create it gives you this axis, which basically you tell, oh, the value is from 1 to 0. You tell, okay, 1 is the total of their size and 0 is nothing. So basically I'm telling you, you're going to start with your normal size, but then as your life continues, you're going to start decaying your size, and then it goes down to 0. So now they're not just getting transparent while they die, but they're getting smaller and smaller and smaller. Now let's add a little bit of noise. Noise, it's also another that's heavy in processing times, but it gives us this cool effect, which basically create random noise throughout each one of our particles. We can decrease a little bit the strength, maybe a little bit the frequency, right? And whenever something moves, it will create this awesome effect. Now, why are we doing all of this? Like, why are we playing so much with this particle effect, right? So let's say we put this at the end of an arrow and we shoot this arrow, right? So you will be able to see the trail of the arrow, and because it will follow the game object. So let's say it throws an arrow from here to here, you will be able to see this trail effect, which I think it will be pretty cool. Right now we don't have an arrow, but we have a sphere right here. So what we're gonna do is we're gonna grab this particle system and we're gonna just drop it inside our sphere. That in our hierarchy right here, that will make this particle system a children of my sphere, a child. So whenever my spheres move or wherever my sphere goes, my particle system is gonna go with it. Of course, my particle system has its own location, right? Its own position, a different vector. So if I change this vector, this position to 0, 0, 0, because the parent is the sphere, 0, 0, 0 means its origin point, which it will be the parent's point. So I know the particle effects doesn't react right now, but if we put it on our play mode, now our sphere have this really nice effect to it. Although I'm kind of getting cringy of all this white, let's create some materials and start giving a little bit of life to our scene. So I'm gonna go to assets right here and I'm gonna right click. Here I can create different things. First I'm gonna create a folder just for, I'm willing to create a little bit of order in all this chaos. So let's create materials. Inside my materials, I'm gonna create 2 materials, actually 3. Let's create 1 material and we call it floor. We can create a second material and we call it blue. Now we can create the third material the same way, but in order to make it faster, a shortcut that you can use is Control D or Command D if you're in a Mac, and that will duplicate the material. Now you have blue and blue 1. Right? You can change the name right here. Oh, don't worry, it wasn't letting me. Give it red, right? So we go to red, we go to albedo, and basically here we can change the color of that material. It can be opaque, cut out, fade, transparent. If we have this type of material that it's translucent, like a window, we want it to be transparent, right? And we can change also the transparency of our material here using the alpha. Most of the elements, like you have seen in different design programs, works with RGB, which basically are the lights color. Some of those programs also have CMYK because they need to print stuff, so they need to use those colors, but there's always the 4th element, which is alpha, which means transparency. So if I want this material in one of my game objects, I grab it and I can go to mesh render material, default materials, and I can look it from here. Or I can just grab it from my inspector and drop it here. Or I can grab it and drop it literally just on top of the element that I want to be inside of. So now I have my red cube. Let's create a blue material. Let's create a yellow. No, I'm kidding. Blue. Blue ball right here. And a floor material. Let's make it this grayish green. Also, whatever change that you do to the material, because it's already linked to this mesh render, if I change it right here, it's going to change also in the material. Right? Something like this. Okay. Now, after all of this, I think we should start getting set our Oculus in order to get inside of our 3D environment and start experimenting how is VR inside Unity. Are you guys good? Are you guys tired? Do you need a break? Water break? Bathroom break?
All good.
Awesome. I'm just gonna trust you, man. Like you're the only one who responds, so you're gonna dictate the entire workshop. So cool. Before that,
You're too socially awkward.
so right now, I only have an Oculus, but let's say I have another VR headset. The first thing you want to do is to set it up on your computer. the way you do so is literally you just need to connect it. For the Oculus, you will need to download the Oculus application. I already have it right here. So it's right here. When you connected the Oculus, you can connect it to your USB-C cable. And as you can see on my devices, I do not know why I have two Oculus Quest 2, but I have my Oculus Quest 1 right here. This I will need to use it because whenever I turn on my Oculus connected to the Oculus link, it's gonna launch my Oculus app, and that way I'm going to be able to connect to the Unity editor. So if I'm not mistaken, also another thing, okay, another thing that I put here in the Unity VR course doc, you will need to enable the developer mode inside your Oculus, which I put the link right here for the Quest, or if you have a Rift. Basically, you do it through the phone that is connected to your Quest. You just need to go inside it, go to devices, settings, and then you just need to type developer mode. You just need to click it in, and then you will have your developer mode on. That will let you to start like tapping and creating an application inside your Oculus. That's cool. So the first thing that you guys need to do right here in order to put your Oculus inside of this space, you will go, this is what you guys pay for. So get your crayon. So you get your package manager. Inside here, like I was telling you guys, here are different packages that are already installed inside your Unity editor, from Visual Studio to Unity AI, TechMesh Pro, blah blah blah. Now you have Unity Registry and My Assets. My Assets are the assets that you have bought on the Unity Asset Store, which if you guys find it is right here, like Scene Game Asset Store. So wherever I buy, I will see it right here. But we want the one from Unity Registry. So basically all the ones made from Unity. And inside this one, there's one called XR Plugin Management. So we want to tap that one and we want to install it. Just letting those C# scripts compile. This is the part when you just chill a little bit. Now that it's installed, and you can close this. Now if I go to edit project settings, now I have here my XR plugin management installed, and with it I have come with a lot of different XR startups. Now it depends on what you are developing for. You can even have a Magic Leap, you can have your Oculus. You're developing for Oculus Quest, you want it to be Android. And this is when somebody says, but why Android? Okay, so the Oculus Quest basically works with an Android operating system, because literally these guys have the brain of a cell phone, right? That's why they're not that powerful. The Oculus Rift and the Htc Vive are actually more powerful because they have a high-end computer behind it, right? They have that horsepower behind it, so they can do a lot of things. So let's just check these two. Oculus, and then inside of Oculus, see, I didn't have that Oculus before, but now because I check in, I have this option. And now it tells me like, oh, target the devices. You can actually target device the Quest 2, or the Oculus Rift if you are using a computer, and that's it. So now that you did this, there's a little bit more that you have to do because it's still in development. Sometimes with each, sometimes. Now, sorry, I forgot to mention. This is very important. You should have your your Oculus on the latest software update, and as well on your Unity, try to get always the latest, because they are the list. They're where they fix all the bugs. So if I go to project, no, there's two, yeah, edit project, sorry, not preference, project settings, you will see one that says player. Here in player, you can switch the Android settings as well, but here in players you will go to other settings, and then it says Auto Graphics API for Windows. You need to take that off, and you need to, it's using Direct 3D 11. Okay, if it doesn't have Direct 3D 11, it has another one like Volcan or OpenGL Core. Take that one off. You just click it. First you add Direct 3D 11, click the other one, and you just want to click the minus button. That will take off that graphics API, and we'll start using Direct 3D 11. You need to make sure that it's set up that way. If you don't, then you're gonna get a black screen and you won't know why, and it's just chaos after that. So now that I did all of that, if I right click on my scene, there's a new option right here that tells me convert my main camera to an XR rig. So it's going to grab this camera and it's going to create an XR rig about it. This is the simplest rig that you will find. Like, it doesn't have, oh my god, it doesn't have too much. It's basically just the camera, so you can have the head. Right now we're going to import some simple toolkits where you guys can start like playing with grabbing and also room scale configuration. But for now, let's make this one work. If this one works, the next one will work too. So once that I've done this, once that I plug in my Oculus and set up my developer mode into it, if I press play, just give me guys a second. Oh shoot, sorry, I didn't have my Oculus Quest connected to my computer. Make sure that all your cables are connected all the time. So whenever you connect it, it will tell you, do you want to allow the access to data? And you tell it, yes, you can trust in my computer. And then it will tell you to enable the Oculus link. And then it will basically launch it like if it was like an Oculus Rift. Just give me a second, guys. So sorry, guys. Development process can be a little bit tedious. It's asking me to redraw the boundaries. Let's see. Okay, I'm just gonna do one more thing before I show you guys inside of it. I'm gonna restart my Oculus because it's acting a little bit buggy. Okay, guys, for some reason the Oculus link is not letting me work. I think it has to be with the fact that I'm screen sharing and that is using the graphics card in order to do that. So it doesn't let the graphics card of it kick in so I can tap inside the Oculus Quest. Sorry guys, I didn't think that would happen. But mainly so hard if you guys get here in your computers and do that right now with your Oculus Link, it's going to let you, whenever you play mode, go to play mode, you will be able to see through your camera, through your Oculus Quest, and you will be inside that environment. I'm just gonna try something else right now really fast. Just give me please a second to see if we can figure it out.